while because YouTube. And it is alive. Okay. Well, there's nobody here, but I didn't make an announcement because I'm like that, you know. Anyway, so of course, neutron decay cosmology, because this is where my brain is at still. So let's do a review. We're going to look at the universe. There we go. The yellow would be the universe if it was all an even, like, Big Bang, if the Big Bang, let's forget about the expansion part, just in terms of a distribution, right? Yellow is even distribution around this Planck particle that is the core of the universe. Actually, it's the whole circle, let's pretend. Okay, this is just a model. These aren't real proportions, but what is significant about the cardioid, which I love, as everyone knows, is that if you look here, right there, it is, in theory, exactly flat, right there, exactly, as flat as you could be. But as soon as you move it a little bit, then it starts to actually veer from uniform. So this purple line, blue, whatever you want to call it, can represent the full range of gravity, or the full range of anything, but it works very well for our purposes, gravity. So we see a proton here, and then let's consider this the electron orbital, okay, the amount of room it takes up. So if it's this is a hydrogen atom in deepest space, this would be about apparently 1 meter. One single atom takes up 1 meter of space. That's the distribution, okay? And then as you go closer and closer to event horizons, wherever they happen to be, but as you traverse the gravitational curve, you slowly go either direction. Doesn't matter which way you go. We could make this 3D. You don't really have a choice. When you're at the very least place, everywhere is downhill. So we start downhill. We work our way downhill. And gravity is getting more and more. And I didn't figure out how to do this yet. But imagine this surface as being like how big the hydrogen is. So it's getting squished and squished and squished and squished, squish. And at some point it's so squished in here someplace that it wasn't hydrogen anymore, and now it's helium. And you know, in theory, if we did this, we could chart out all the elements would lie someplace on here, all possible densities of everything, because energy, mass, equivalence, density would be on this chart until right there where you are radial, 90 degrees to where you used to be, radial rather than tangential, you are at this little node, which would be like the surface of event horizon. You could smear this around, but don't get confused by the idea that because it's represented as a dot here, it could only be a dot. You know, you can have this dot be a sphere as big as you want. Right now, it's a Planck sphere, the size of a Planck, because that's the smallest it could be. But you shove a bunch together, and you have a black hole, right? So, gravity. So I'm going to press this little button, and then we'll do a sweet little thing where it goes do. See, you're going along the gravity curve. You're going along, and now all of a sudden, it gets tighter and tighter. And now you're at the most dense. Okay, so now you're at the event horizon. So in neutron decay cosmology, the premise is that essentially it's sort of like whether it's transferred as a shock wave or something through this Planck particle that's at the core of the universe, at the most dense place. We aren't. And your distance creates the energy. Anyways. So let's back it up. And now, maybe that's where we are. And there's deep space, deep space. I haven't actually done the math on this. You can say there is minimal. There is maximal. As soon as those two things were set, I don't know how to do that exactly because numerological stuff is not really my forte. I'm a topology person, shapes and what they create. So it would go through there, reappear here, the neutron falls in here, it appears here, decays into a meter. The difference between these two, basically when this expands, because this was this, and then it becomes of 1 cubic meter, that is dark energy. This is dark matter, though initially it may not be orbital like that. It would just take up a lot of room. Okay, so there. And notice the cardioid. Okay, so now we are going to switch. I had notes. Yes. Okay. Hey, there's people watching. I am shocked. Top chat. I don't know how to even see the chat. Okay. Apparently there's chat. Hey, Leo. Does anybody want me to go back and retrace anything, display anything special? This I totally ripped off of and just readjusted from Daniel Montrard. He does a lot of stuff on geocalc. And I just relabeled and modified some colors and this and that on a cardioid diagram thing that he has. So let's switch up though, because I wanted to go to boom. Okay. There we go. So this is basically exactly the same thing. There's the sphere. The blue is the Planck sphere. The yellow is the hydrogen that has now made its role and is now at the, at the node, at the event horizon. Notice how they're oppositional like this, of course. These charges match. And I don't know how to make it roll, but it would roll like this, and that's when it would be hydrogen, at its largest. And then as it traverses, as you go down, you get more and more dense, more and more dense, more and more dense. There's a great video, River, Gravity is a River or something on YouTube. I've posted it on Twitter. It's just like awesome regarding this. Anyways, so then we're at maximum. Okay, I'm gonna get rid of the sphere because it's blocking my view. There we go. Now, I just made this, and this is like a mesh. This is a mesh adjustment for the cardioid. It doesn't really adjust the form, as you notice. It's a meshing thing. It's sort of like the modulo of the paths on this, and if these points connected. But there's an interesting weirdness that I found, is when I take this, and I'm going to shrink it just a little bit because it's going to get a little bigger. So again, this is space, right? This is gravity. There's maximal, there's minimal. Now you think, oh, cardioid, that sort of displays the shape of the universe in that energetic curvature way. And then I was like, oh, well, what can we do when we play with this shape? Okay, I personally, I don't know why it's the figure 8, because we're going to exactly regard this. Boop. Okay, stop. I'm going to make this exactly half pi, because either 0 or pi are the extremes of the cardioids, because it's matching interlocking cardioids. So it's 157, boop. Okay. First, just look at this, right? They exactly match. I didn't set this. This is just like a unity thing. Phone call, probably my brother. Just a second, people. Hey, Martin. I mean, yeah, actually, I mean, in the middle of a live broadcast thing on YouTube, but it's all cool. It's like, no, it's no big deal. It's like very chatty. So anyways, but you're heading down. What you doing? You still getting some pieces? Yeah. I'm going to. I didn't have a chance and stuff, but I'm going to talk to her. Okay. Can I call you back in half an hour? Yes. Yes, I will. I will try to. Cool. Thanks. Bye. Sorry about that, peeps. Yeah, I know. I'm just chilling as we hack reality. So there we go. So that's the cardioid sort of like expanded along the z-axis. And so this is my whole thing with the figure eight. I don't understand, and I'd be curious to know if there's like sort of the rationale about the figure eight. Because to me, the trefoil is a way better diagram because it's got these three. These are like the three fields. Each of these strands at that point, it's like each of these, if you made a slice through, each of these is running 90 degrees to the other one. Like it's a three-phase motor built into itself. And I believe this would actually be a self-tightening plasma knot, since this loop puts a constriction on here, which would intensify this, which would make this loop more intense, crushing this section of it, etc. So this is why I prefer, or like I think, the trefoil knot rather than, but if there's a good justification for the figure eight, I'm totally open to hear. But this is one of the interesting things. Okay, so that was a cardioid. I expanded up the cardioid like this, and this is just all I did is change the shape a bit. Right? This is where's the diagram? Even if I want to see, doop, equation. There we are at the bottom. That's the curve of the cardioid here, and you can see it'll disappear on this side when I turn it on and off. So that's the equation for the cardioid right there. And you can see where I put shape. Adjusting, it's like theta relative to shape, so it's like just a balancing out basically on that one axis, on the z-axis or not. So let's zoom out again because I want to. Okay, so most people don't like when you see the trefoil knot. This is the standard version of the trefoil knot where it displays the tray of the foil. But there is when you look in knot theory, the trefoil knot is usually displayed more like this. And what it would be is, let's say, this is the matter. There's the catastrophe. There's your antimatter orbit. But really, it is a single strand, so therefore it's a single membrane. It's just there's sort of the two apparent sides of the membrane. And then, yeah, we'll just continue with the shape thing. Oh, and I'll even, wait, I've got another. First, let's finish the shape thing. So let's go to up to top. Because it looks cute. Oh, too small. Gosh, I love this program. Thank you, GeoCalc people, for ever making this. Okay, I'm gonna let it come down to the balanced form again. Oops. Hey, hold it. 2, 2, 5, 7. Okay, 5, 7. Now, this is like the meshy thing, right? Like this gets to decide. It looks really sweet, doesn't it? What a sweet animation. And this N thing over here is just sort of like a meshing. Like if I put it to 1, it hardly looks like anything because it closes off onto itself so fast. Boom. Right? There's one orbit. Yeah, I don't know what the 5 and 7. Did I say 5 and 7? So that's sort of like one life orbit, and there's a catastrophe. Basically, when you have anything to do with those two balls, you're in the catastrophe zone. So I'm just going to make this an adjustment. I'll show you. It's like 1, so I'm going to make it 1.1, so it's not a perfect orbit, and all of a sudden, right, it spreads out a bunch because I right now have, when I'm making this, I'm letting it, orbits times 2 pi. Yeah, and I've got 20 orbits. I'm allowing 20 orbits. Right, let's cut it down. Actually, let's do settings, max, 3 orbits. That's all it's going to be allowed to do. Okay. So this is not going to draw 3 orbits. 1 orbit. 2 world lines. 3 world lines. And now it'll undo those world lines. But if we had a crazy number of world lines, you could see the overall shape of the universe, right? I mean, in this model. So let's make this 253 world lines. And we'll give it a minute. Because I picked 1.1, we'll get 10 orbits, right? If I was 1.01, then I should be able to get 100 orbits. It's thinking. There we go. So this is that cardioid expanded out. Okay, so what I'm going to do, though, is I'm going to set this for a half, because electrons have a half orbit. And it's a single-sided universe with apparent 2 sides, so each one actually only gets half of the universe. And what do we get when we get that? It's still going to draw all the hundreds orbits, but it gets reduced to 2. So this is kind of why I have a fetish for the trefoil knot over this, the figure 8. So that's why I really want to know why the figure 8, why they prefer that. And let's change the shape back. That's going to take a minute because I still have 253 orbits. Let's change that 25.3 orbits, and that will be a reasonable calculation. It's like doing iterations or something. It's the brainiest thing. So there we go. So that's basically the cardioid shape of the gravitational thing. It's upside down. However, which way you want to have it, but it's actually a double layer. Yeah, you use the term capacitance, and I think of it as just like energy density, really. Whatever it is, it's, you know, as you squish up space, it's like space is a real thing. If you took 1 meter of space, that 1 meter of space has a certain amount of energy. If you now squish it and actually change the metric too, but relatively, so it doesn't matter, you know, since everything's relativistic, if you change the metric, you've made something denser to everybody else around it. So it's basically like, I think really what it comes down to is 1 neutron, 1 proton are almost exactly 1 cubic meter of space crushed down into that much space. And that's just pure density is a way of thinking about it. Here, I'm going to reset this a little bit. But I wanted to show, wait, let's go back to that half. That's exactly half. Okay, how this is the trefoil knot. That was sort of like the initial focus of this animation that I set up. And there's the cardioid, and then we're going to set this to something a little more 5, 1. There we go. 515. And the blue is sort of like the Planck sphere in the middle of the universe that everyone gets sucked towards. You know, it's like you fall from here towards here. This is a sphere of light. This is the event horizon. This is event horizon. This. Yeah, no, Buckminster, there's so much still. I go back to Bucky's work all the time. I actually have. Where was it? Oh yeah, I was doing his whole, there's this thing that he made where it's like, so even though these are 60, let's pretend that those are 90-degree angles. So this represents the 3 different oppositional fields. And then the other 3 fit basically as the antis to everything as an interlocked phase singularity. And that was his whole, yeah, that was part of his whole theory. And it's like interesting because it's like, okay, just expand it out, right? It's the tension there. And a way I think of the universe is like, you know, potential energy is sort of like one path is only 1 Planck thickness. You know, like that's 1 Planck distance you just traveled. And then this is 13.8 billion years on average or something, you know? And it's the tension between those 2 which drives the universe. That's like the energy tension. Exactly. Yeah, that's what the event horizon is. I describe them as it's almost like one-way pressure release valves. The pressure gets denser and denser and denser, and you hit the event horizon, then you get flung out. Only on the other end, there's lots of space. That's where you relieve the pressure. It's like, psh, and it's going to the vacuum, which actually creates the draw there, because the release of pressure there creates a negative pressure. Therefore, it draws things towards it. This topology is sort of like self-driving is the thing. Because of gravity, because of this contortion, because there's a ball of light there that's got basically like infinitely low pressure at the surface that sucks everything towards it. In a way, that's what gravity is. Yes, and it's funny because I don't know if one of my videos, the Woo and Why, talks about how it's like, wait, if this is true, if this is really like the event horizon is a plane or sphere of photons trapped in orbit 90 degrees to us, that is still a sphere of light. It's like a skin of light. This is why everybody thinks that. We are all falling. And in our cells, like every single atom of us, the Higgs boson essentially is the minimal thing. That's why we have inertia. The Higgs boson is a photon of minimal wavelength trapped over its own gravity, is whatever other people want to talk this, like people who have their rotation models. It's the rotation thing. Yeah, they're all the same thing. Yeah, and all of existence is in free fall forever. You just keep on falling. You fall right through the event horizon, and now you're in deep space, and now you're falling towards the event horizon only. Suddenly, you're 14 billion light years away from it instead of being at your nose. I mean, you couldn't possibly survive. You would get ripped apart. The tidal forces are so great. Nothing except for neutrons. Like everyone's reduced to their essentials, I think. How you can explain persistence of like collective consciousness, all these kinds of things, is that when you hit the event horizon, right? And this is even recognized physics sort of thing. That pattern that you impose on the surface of the event horizon, that interference pattern that you create at the moment when your atoms get integrated, each one, you get spaghettified, but you're still there in a long, skinny line. The information is still there. All that is now embedded in this sphere, right? All of history is embedded in that sphere. So it retains it all the time. Even though there's only now gets modified constantly. You know what I mean? Like now is always updating itself. This is how the computational models fit into this. Now is always updating itself. There's only takes one Planck second, and this Planck gets redrawn on top of this little ball. You know, it's like a little ball that's sitting there, and you're drawing, and it keeps on rotating, and you keep on drawing, and you keep on drawing, and you keep on drawing. And yeah, you start drawing over stuff, of course. You know, that candle, you know, all things used to be something else before. They get redrawn over. But that's the way it is. It's constantly updating itself. Everything is constantly falling towards the singularity. But as soon as you are at the singularity, let me call up one more of these. Harkens back to a previous. It's a variation on this, but it displays even better. Let's check this shape thing. Okay, let's see if this does this to it. If I increase perforation, maybe. Right? That's like a magnetic field, because that whole thing exists. The whole magnetic field exists on our side, and yeah, it's reciprocated inversely in the antimatter world. But there's a closure to magnetic fields. That's why they're symmetric. Why is our universe not symmetric? Is because we're actually only one side of it. That's why you get the chirality thing, right? We're only half of that. The reconnection is through, hey, memes. It's an impromptu, oh yeah, this was the core of it. So this is the whole why I love the trefoil over the figure 8, and I really want to know why. I really want to know why the figure 8. this is Penrose like it is that only our time frame is 1 Planck second. It's exactly Penrose cyclical, but everyone's got convinced, and it's going to come out eventually. I really just believe that the whole Hubble tension thing is like complete misinterpretation of data. That the Hubble Doppler is purely an artifact of the curvature of space-time. I have that someplace. Let's call that one up. Hubble observer, there we go. And I can't do this justice because I don't have the skills. Oops. Okay, so let's pretend an infinite universe. Relative to us, here's the universe, right? It goes on forever and ever, and we're at one spot in it. Oh man, what are you talking about? Well, let's get a little more local, because that's like quadrillions of light years we were just looking at. Oh shoot, I gotta do this properly. Let's get a little more local. That's a little more local, but still can get way more local than that. There we go. Okay. Plane, perfect. Boo. Okay. You are observer. You exist in the center of the universe because every observer always exists at the center of their own universe. Kind of goes with the sitch. Unless you're tripping. So, now, space-time, even if clumpy stuff didn't cause a bend in space-time, the virtual particles should. An energy density is an energy density. Yes, they all are. We're about to have a total renovation of physics where all of these views sort of come into a holistic, cohesive view, which I believe will be fluid dynamic, because it's the only thing that accounts for all the aspects. Exactly. So, regarding this whole like Doppler thing, the Hubble. So there's the observer, and the energy of space imposes a slight curve on space. We don't notice it. And it's like, well, how would you measure that exactly, is my question. How exactly are you going to tell if space is curved? And I say the Hubble Doppler is the evidence. It is a frequency shift in light dependent on the amount of the gravitational curve it has had to overcome to get to you. The same way that black holes are blue near the high gravity, it's sort of the opposite. And maybe I should make this an opposite curve somehow. But they go blue because they're localized. Like they terminate within our world, within our visible universe. The universe doesn't terminate within our visible universe. We only get a tiny fraction of it. So that's a bit of the curve. And it's like, oh, at a certain point, the light gets dragged down curvy enough that it's like red. And if I knew how to do this, I could even take that, because think about it. Let's say there's, any of you guys know that like structural color thing, where it's like, imagine there was beads, little spikes all over the surface of this, right? When it's flat, it's a certain color, blue. As you bend it and you separate and you create a larger gap between all those spikes, the color shifts downward because you lengthened the wavelength. So that's exactly what happens. Space gets stretched out because there's so much mass out there. There's an infinite amount of mass dragging at the universe, and eventually everything just gets dragged down till it's all going to be like radio, and we can't see it because you start to lose resolution as well. And this is my explanation for why the Hubble tension has to do with the fact that they use two different objects, and each object creates its own gravity cone, the other kind, yeah, like inverted to this, sort of, right? That goes blue shifted, but depending on the predominance of that sort of curvature, that will adjust your red shiftiness. Like a blue star looks closer until you can find some kind of like a specific line to match it with, or you compare it to other things and you say, yeah, but it looks like it belongs to that cluster, like considering its size, etc. I mean, there's a bunch of factors. It's still very iffy, this whole, astronomy thing. Our best guesses are still guessy. It's not that easy. The data is not that clear. So we're doing our best. So that's the Hubble observer thing. But see, I didn't know this, memes, if you're still here, that thing about the electron and the trefoil. Because, that's the thing. This is one form of the trefoil which totally maps onto cardioides trefoil. Boop. Nope. What do I want to take away? That's what I want to take away, and now I'm going to do shape. I swear, just give kids, like, when they go to school, just give kids some, like, decent pads with some cool software like this on it, of various kinds, tiling software, all kinds of stuff like that. Let them play, let them explore. If they have questions, you have somebody around as a resource, come on. Like, I swear, it's like, my dad was a science teacher is the thing. So literally, like, I didn't get Legos, I got a chemistry modeling kit. That's what I got for Christmas, and that was like awesome. Like, it was all, instead of being a toy thing, it was the real thing, It's like, why don't we have kids doing that? So there we go, see? It's the cardioid, but it's this. But this is also, wait, and I can get it, maybe, it's hard to get back into the 3-phase version, but it's also the 3 fields, all 90 degrees to each other. Gross. Doot doot. Right? And I don't know if you saw it, memes. I posted that this is the simplest knot possible. You can't have less of a knot than a trefoil knot. After the trefoil knot, all you have is a loop, is the unknot. There is no simpler knot than this. This is the thing. Which again, it's like, I'm very path of least action. It seems to be, slack. People who don't know the Church of the Subgenius, slack. Why is anybody working at anything? Because everything should just happen, because nature does. We just have this very poorly organized is the thing. Why isn't my lunch sitting in my backyard already? More slack, right? Infinite slack. It's an intentional organizational structure is the thing. But we won't get into conspiracy theory stuff now. But I don't know if you saw, I posted on Twitter this link to this, the compactified time. I looked up compactified time because I had never ever heard anybody ever, and I Googled it once before, but I came across this paper. And they took standard model Schrödinger stuff, whatever, they're physicists, and said, well, what if we closed up time? What would happen? And what happens is you have a universe, it's like a closed state universe, which has the same entropy at all points. And this actually works with, that was a really complicated thing to work out with neutron decay cosmology, to get that all to balance, but I think it does. Because we don't really know how long black hole decay is and that sort of thing. Like there's a lot of room there. I do not just like, I'm not going to accept that just, well, so-and-so's equation says this. It's like, there's Lorentzian interpretations, there's this kind of interpretations, there's different kinds of metrics and space-times and stuff. There's a lot of room in there, you know? But my thinking is that, consider a neutron. It's a small drop. It has a certain amount of curvature to it. When a neutron joins the surface of an event horizon, which is a singular surface, it is smooth, it is perfect. It's almost like one ginormous neutron with a weird surface texture of everything. And so it sort of loses its identity. And then this I solved with a weird thing where either like the information gets dropped off and the kinetic energy can get dropped off at the event horizon, because at the event horizon, your kinetic energy is basically equal to your mass at the very moment of inversion. So what you do is you drop your kinetic energy off so that the event horizon can get bigger, but you retain sort of that singular self-identity in the neutron of the Hamiltonian or Lagrangian or whatever, like the singleness, and you emerge in deep space and do the trip again. Yeah, that's the thing. It's got an extra convolution in it. And that actually, like, I pointed that out to Thad the other day, because in topology theory, the amount of curvature describes the energy of a surface. A sphere has no energy. It's a perfect, it's just there, right? It has no tension to it. There's no change in energy density anywhere. The cardioid, specifically, describes the variation in energy density across the surface of the universe to us, right? But there's this cardioid, and similarly, since as we go, it's actually a double layer that we didn't really notice before. And it's also the other cardioid. Right? It's sort of both at the same time, and that gets represented when we pull it down here. And if we sort of thought of this, think of this a little sideways for a sec, you know, where it's like this side sort of gets pulled down and that side, because it is two strands interlinked as one. So as a knot, this is the minimalist energy knot. And can I get that up? Wait a second. Shirley and Crows. Let's just get Shirley's surface. this, which I've called Shirley's surface, because it was actually, like, as I said, it was pretty much unrecognized. Is it like it? People must have made this shape, but nobody noticed that this is actually a one-sided figure. If you notice there's no tension there. That's a smooth path. You're just falling. And at the very core on this in this equation, I can't spot it, but the resolution breaks down at a certain investigation, and we're looking like this is unit. So we're getting it to do calculations that are like really, see, it doesn't even want to go there. This program. It won't let me look any closer. But that's a problem, I think, in the nature of the calculations, that it gets to be difficult because these are strange moments. Because that's like the singularity, where the two intersect, where the matter and antimatter intersect. Let's imagine the surface is matter. When you hit the event horizon, suddenly you are actually now on the inside. So now you're antimatter. And then you're matter. And then you're antimatter. And then you're matter. But it's both at the same time, which is why I'm actually also relating to quantum mechanics, which I don't do, but think about it. It's like, you have a voltage or whatever it is. It's like you have an energy, and the energy gets larger and larger and larger and larger, and then renormalization. And when you come out the other side, you're now just like a little bit, but on the other side. And if we had the cardioid on top, do I have that on this one? I don't. Wait. Let's do this. Let's take that. Let's take that. There we go. So there's Shirley's surface, and basically, like, the way it would be is, this is, right, there's the hydrogen that exploded, and then you come around this side of Shirley's surface. So this whole half is a unit. And then this top should be metriced so that it's like a half and a half and a half and a half and a half. It's squared, right? It's a logarithmic increase to sort of match the curve of the cardioid. But again, I don't know how to do that, but this is how these two shapes sort of interlink. That this is the... can I do this on the fly? There we go. Okay, I'm going to modify this right now. Instead of n times. Damn. Wrong. Okay, first let's get n, something useful, I think. There we go. Oh, shoot. Go away, little number. There we are again. And in a way, it's compactified time which allows this, because compactified time causes that density. Well, if space is a dielectric fluid, and gravity causes flows in that dielectric fluid, then a little known physics fact is that flows in a dielectric fluid cause charge separation. The same way when you take two pieces of plastic, right? And when you pull them apart, it's like it was one thing, and you are literally like pulling apart bonds when you do that. Now my hands are covered in oil and stuff, so all the charges get sucked up and used. But if you were two flat plates of plastic and you go like this, you can build a wicked charge. The further away they are, the higher the voltage between them. As you draw them, you're stretching it out. You're literally stretching space and creating this voltage that they want to be back together again. And you are creating this pressure between them. This is a very real thing. Well, this happens in fluids too. This is a solid being sucked apart, but when you have a fluid, if you have a divergence in the fluid, then you now have this charge separation that wasn't before. We had parallel. You go like this. This is negative. This is positive. That's just, it is all the same. Casimir force is really more about having one is having the trapped, if you have a cavity, then that if you create a cavity with flat walls, in between this cavity, there should automatically evolve all the frequency of standing wave that can fit in that gap, right? Because they just will. And then outside of that gap, you have all the other frequencies too. So that creates this differential in sort of like energy pressure, because you have less here in a way. But if you conform it, then you start to have this weird thing. This is, again, I think we might be able to make self-driving. There's these crazy particles called Janus particles. I don't know if you've watched the evolution of them. They're like little tiny nanoparticles. And all you have to do is like coat them differentially, and they will like do things like spin in the water or whatever. Like by modifying the geometry, you can make them self-propel. And there's a Marangoni thing I put on Twitter as well about a Marangoni current thing. But consider this. Yeah, exactly. Casimir force. This is wide and flat. There's no charge density here. It's very, there's no pressure. Imagine just all the spikes here. That node. Oop. Down inside there. They're all like, just imagine there's electrons on the surface of this thing. Let's just imagine that, right? This whole thing is coated in a layer of electron shell, which is the way things are. They all have a little bit of a negative charge. Let's make it a metal. It's like a layer of down here. Down there. There's going to be a tension because they don't want to be pointing at each other. They want to have some space. They got no space. They're all crushed up. They're like all, again, this is whoever it was that uses the dielectric thing, right? Like there. This is where the tension is very high because it's all concentrated. You got no choice. You got no room. This is sort of, I think, the notion about that UV, that microwave drive or whatever. Like, let's say you put a microwave horn here. Because you give this room for the waves to expand out, it creates a low pressure, like a low energy pressure, because the dissipation is so fast from there that it creates a low pressure front in front of you, sucking you towards it, is I believe the premise. I'm not sure it works. It might be like one of those, like, you know, blowing your own sail thing. But yeah. See, any of this terminology, I really don't even, I need to learn. But it's just like, it just seems like we can use English. Yeah, exactly. Two symmetries. They're like opposition. It's like two quaternions interlinked, creating an octonion, but they're inversely reciprocal. So that it's like as soon as you rotate one, the other one's rotated exactly the same way. This is what I say about sort of compact time forces this. You know, if this is time, this is now a membrane of time. This is the membrane we all share. This is an inflow, and it's outflowing from the other side. This is spinning clockwise, counterclockwise. If you see it this way, oh, from the antimatter side of things, they see it as spinning clockwise. It's the same thing and it's spinning the same way. It's just we're on different sides of time. The charge differential, all of that is, I mean, that I go into more in, let's, it's still there? Uh-huh. There we go. My original neutron decay cosmology. Yeah, that's good. This is my initial diagram of it. It's like, well, if this is time and you're rotating in plane, flat, then you have no charge. You're not displaying any sort of qualities, really. A neutrino would be a weird wobbling thing that appears to be spin, but doesn't actually have an inflow or an outflow, therefore no charge. It's just like as if this was like going that way. Then electron is actually a proton on the other side of time, which is how you complete it, half spin, half spin. It has to compensate, because otherwise you'd have charge on one side and nothing on the other, and then you have tension, and that tension is friction, and the world is friction free. Everyone's falling all the time. So this sort of, and somehow this connects to spinners apparently, but I don't really know that. And this is where I first thought of the Shirley surface shape, even though it was just out of like, okay, how do we work this? How do we make it so that we can have a shape that will do what we need it to do, so that when you fall in on one side, it balances itself, and that way all a single-sided surface. There's gravity, and I don't think we need anything else besides gravity. Yeah, why law of conservation? Because the universe is a single piece. Oh yeah, and I think this is how I think of event horizons. It's not like, I don't think there's inside the event horizon is the entire universe. It's a geometric, like topological inversion sort of thing at that moment. So there's nothing inside the event horizon in a way. There's no, the surface of the event horizon is the thing. In fact, in here might be the theory that this might even be the empty set. And it is the empty set that initially attracted everything to it, to its surface, but you can't share. So it's sort of, we formed a skin where we can all look at the empty set, sort of like, only we don't get to see it because there's nothing there. And instead we look at ourselves across the universe. Oh yeah, this is my whole, another way of thinking about it is that the center maps onto the periphery, so that when you finally fall to here, you are now here. It's a hard thing to describe in 2 dimensions or even 3 dimensions. That's what Shirley's surface is about, though. Is being that thing where you can be on one side and the other, a single-sided thing, which forces conservation, which forces CP parity, like asymmetry. It's like these things all evolve from this topology. We don't have a choice in these things. It's all just, and it's, if this is true, this whole like sort of like dichotomy of expansion on this side and the expansion on this side causing low pressure, which causes contraction on this side, which drives the expansion on this side, which drives the contraction on that side. It's just like, okay, well, that's pretty, it's just like you design that, you don't need anything else. See, fields can be considered here. Yeah, let's just eliminate this again. No, not that. Okay. So consider a field even, and we'll just look at the top of this. And this is something memes, are you still here, memes? You brought up something related the other day. Okay, but like the proton charge, you can't, like when you're looking at an electron atom, we almost infer the proton charge, right? The electron charge, the electron orbits go right through the middle. It's more like this is the point of concentration, which you can never really reach. Yet we have to infer it because it creates the electron field, because every convergence has divergences around it. And it's the divergence, like sort of like, again, the stress tensor on space itself, which creates the field, that creates the charge. It's a flow. If there's a great video on YouTube, the river, gravity as a river. It's like genius. And it talks about this, like, if we just play along with this one idea of there being this ether, quote unquote, this quantum space stuff that's incredibly rarefied and a ridiculous dielectric, then everything else will just evolves from that. The fluid is draining out this tiny little hole. The velocity increases. This is, all these pieces of space are like getting pushed really close to each other, but they don't really have a choice because they got to fall into this hole because there's a hole there. Well, I'm a very materialist, sort of like, I like to take a very, very materialist approach, and like the wave function is there's a real thing, and it's a sphere of compression, or you have a sphere, it compresses, the electron orbital shrinks. This means in space there's suddenly a gap, space has to fill it. Now we have a sort of expanding sphere of laminated space, which was the implosion shock wave. That expands out as it grabs space. It's an implosion shock wave, almost exactly. Electron orbital contracts, space rushes in, creates an implosion shock wave that expands out in a sphere. The wavelength is the thickness of that membrane. It's a superfluid, dielectric superfluid, which creates that charge differential, because it's the outside of that sphere is always going to be divergent and the inside is always going to be convergent. And that just expands until it hits a resonant chamber, which is whatever particle absorbed it. And I think the beauty is that whole photon thing. It's almost like it's like the tuning fork. Sorry, can you say that? How do we see this? I'm not getting to see the chat except at the very moment people say things, and then it disappears. Oh, there we go. Okay, can you model this shockwave 1D time? I mean, a ripple. Space contracts. Where's do I have that? I don't have a model of that yet on this. I haven't created that yet. But I do have a few, but I mean, just imagine space contracts. That draws, or like the electron orbital contracts. This means space has to fill that gap, which means that when it does this, all that space gets turned into sort of like a bunch of radial divergences on the outside and convergences on the inside. Now that's laminated, which all the poles are in alignment, and now that expands and travels through space until it hits something that's the right frequency. But it's like tuning forks, right? Like, only you have to be tuned. A C can trigger another C. It could probably trigger the octave up or down C, maybe, depending on what the timbre is, but sine waves got no timbre. So therefore, they can only match exactly what they resonate with. It's like a three-dimensional ripple, right? If there was an inflow, then suddenly you have this spherical lamination, which is the wave function. The totality of the probability wave function is a sphere. It's exactly that. It's everyone's describing the same things just differently. And I just personally find that the nice thing about a fluid dynamic model is that all of a sudden neutrinos make really good sense. Well, everything moves at C all the time. Right, so that would be like a bit of a compression wave, but space is not very stretchable, right? The metric is gravity, which is C squaredness, or like invert C squared relative to your energy density, which is why you need ridiculously high energy densities to modify gravity. Though they've done it, right? You heard about they took two super high-powered lasers, fired them parallel to each other, absolutely parallel to each other, and they attracted each other. Their paths diverted towards each other because each created a little bit of a curve in space-time, but just a laser, no matter. And yet it displayed that, and I think it was like local. It's like on Earth they did this. So that's pretty amazing, actually. That's how strong those freaking lasers are, is what's part of the thing to remember. Do not stand in front of one of those things. Can you imagine? Like, what is the? I don't even know what the frequency is, but how can you stand? How could you stand a gigawatt laser, no matter what frequency it was? I don't know. It just like totally pull some Dr. Manhattan on you or something. Anyway, okay. I actually have to go. I got to get some things done. Yeah. Okay, and this is the whole thing about the like the time compactified time too. It's like explains the electron, like an orbit here as an electron has to be compensated by an orbit here as a positron. Why photons are their own anti is because they are both on both sides sort of simultaneously. They're balanced that way. Okay, I gotta head. Yeah, I got painting to do and this and that. I'm in the middle of renovating this house. But thank you all for joining me. And yeah, let's do this again and we can do a group one sometime. Like do that go live together thing. No, thank you guys for like entertaining my delusions. Peace out. Have a beautiful day.